project number 2. The only thing you can't do is finish it right now because we will be covering the full information for project number 2 next Wednesday, in Wednesday's class. So this project is due 2 weeks from a week from Monday, which I think is like, oh, what is it? 2nd, 9, 8, like the 15th or something. But you can definitely get going on finding your data set. You can get going on plotting it in GeoGebra and doing all of the first part. You don't yet know what, unless you've had a little bit of statistics before, what a correlation coefficient is, which is part of it. And so there's just a little piece of it that you need to wait until next Wednesday's class. So today we're going to finish up section 2.2, and we're going to focus solely on piecewise functions today. So let's get going with piecewise functions. So Adam, want to start us off today?
I just had a question about videos online.
Yeah?
I wasn't able to find like the last 4 classes.
Oh, well, let's take a look. Okay. Okay, go ahead, Adam.
For example, tax payer, municipal tax code, scales that classify if you charge credit cards, only part of the situation.
Okay. So there are a lot of real life situations where one formula is not going to do it. And so that's what we're going to, those are the kind of applications today that you're going to be spending time, hopefully a good 20 minutes at least of class today, working on those situations either individually or in your group. So I'm going to lead you up to that point through the lecture and hopefully start with something that makes some sense to you. That's always nice. So let's take a look at the first piecewise situation. So this graph represents a story, and the story can be illustrated with what we call a piecewise function. It shows the amount of water in thousands of gallons in a swimming pool after T hours have gone by. Okay? So this first part right here, how has the water in the pool changed over this interval? Now remember, this interval is the same as writing this inequality, from 0 hours to 50 hours, including 0 and 50. So what I'd like you to do at your seats is to take a minute or two and just jot down what this story tells you from time 0 to 50 hours, what it tells you about the water in the pool. Okay? So would someone be willing to share their creative writing story here about what's going on? I'm teasing. Doesn't have to be creative. Anybody willing to share?
At the very beginning, right?
Yep, you're starting right at 0. Okay. All right. Lenny here. Lenny's story.
The pool began with 2,000 gallons of water in it. 20 hours later, the water increased to 8,000 gallons and remained at that level until hour 30 increased all the way to empty 20 hours later.
Okay, I couldn't get it all. The pool began with 2,000 gallons of water in it.
20 hours later, water increased to 8,000 gallons. Remained at that level until hour 30, when it decreased to empty 20 hours later at hour 30.
What was it at hour 50? Did you state that?
It decreased to empty.
To empty, decreased to empty. Okay. Couldn't get it all. Okay. So I'm assuming that if I asked each one of you, you would all have similar information, maybe, but just expressed in a little different manner. Would that be a true statement? And is everybody feeling pretty comfortable with interpreting that graph? Yes? Okay. All right. So first of all, which of these two variables here would be your independent variable What would be the independent? Jane? Time, okay. Time is on my side, okay. And therefore gallons is called the dependent variable, okay. So over what interval? Now this is a little refresher from Monday's class. When we talk about the intervals that a function's increasing, decreasing, or staying constant, what type of intervals are they? Open. So over what open interval? I didn't put it in there, but just as a reminder. And for those of you who did this thinking functionally exploration, and you looked at the answer key for the questions on here about increasing and decreasing, you will notice that the answer key has brackets for increasing and decreasing. And that's because different textbooks and different authors will use either open solely or closed solely. So for our particular class with this textbook and with my math lab, it's always going to be open when we're discussing increasing, decreasing, and constant intervals, okay? So what interval is the water level in the pool increasing? Someone want to tell me how to write that? Over what open interval? 0, 20. Is that how I would write it? Parentheses, okay. How about water level constant? Tara? Okay, I put the comma in. And how about the pool, the water level decreasing? 30, 50. Okay. So if I gave you a question like that on your quiz on Monday, you would be okay. You'd be pretty cool with that, right? You could figure out what intervals are increasing, decreasing, and constant. Okay. So some people tell this story, and if you notice how Lenny told it, he actually broke up his story to deal with the different pieces of the domain. In other words, there was one story that dealt with this part of the domain from 0 to 20 hours. And then there was another part of the story that started at 20 and ended at 30. So I'm using colors to illustrate the different pieces. And then from 30 to 50, there was another story. And the red interval, the pool was filling up. And in the in the green interval, the pool was filling up. And in the red interval, nothing was happening. It was staying at the same level. And then in the blue interval, the blue time interval, the pool was draining out. Okay, it's the end of the summer, the pool's gone. Okay, no more water in there. Okay, so we need to be able to write a function that describes each one of these different pieces that you see represented by this graph. And since it's not just one piece, it's not just one increasing line or one decreasing line or one constant line, we have to have 3 pieces to this function. And that's what we call a piecewise defined function, okay? So it starts off exactly the same way. It has your function's name. The function here is going to be called g. Then you represent the output by g of the independent variable here is t. And then what changes here is that instead of just being one equation or one rule or one description on the right side, you have 3 for each one of these pictures. So this first line is an increasing line with a positive slope and a y-intercept or a g-intercept at 2. So the piece, the equation for that piece is g of t equals 0.3t plus 2. So that has a slope of 0.3 and a y-intercept or a g-intercept of 0.2. Okay. The next piece here is constant. It's a constant level. It doesn't change any time in that time period. So that is a horizontal line. G of t is 8 in that interval. And then to describe this, our equation still is a linear equation. We don't know the y-intercept from looking at the graph. I mean, we'd have to continue this line in that direction or actually figure it out. So I'm giving it to you. The slope is negative. So this part of your equation, g of t, is negative 0.4t plus 20. Okay? So how do you know which of these formulas to apply to your input? So you have an input, some number of hours goes in, and which one of these do you use depends on what the value of t is. And that's why you need this little piece beside it, because that tells you the part of the story that you're in. Am I in the part of the story where I'm filling up my tank, my pool, and that happens on this interval 0 to 20? Or am I in the part of the story where we're all just hanging out, floating on our floaties, and nothing's happening to the level of the pool? Or am I in this part of the story where the pool is actually draining? So how a lot of people have trouble writing. You can write the interval 30 to 50 pretty easily, but some students have trouble taking this and then translating it to this particular thing here. So how would you write the interval here? Any guesses? And then we can check it out. 30 is less than t, which is less than or equal to 50. Okay, that's fine. Now, someone might argue, couldn't I say 30 is less than or equal to t? And if you put 30 in here for t, look what happens. 0.4 times 30 plus 20. Okay? And what value would you get? You would get 8, right? Because this is negative 12 plus 20, which is 8. It's actually the same exact value up here. When t is 30, it's 8. So that is confusing to students sometimes. Well, what do I do? Do I put a less than here, or do I put less than or equal to? It's really just a convention that as long as your value for t is the same here as it is here, when you put t equals 30 in, then you just sort of follow if you're including that point in the previous interval. So notice here I'm including 20. So here I'm just going to say t is greater than or equal to 20. Since I'm including 30 in the piece above, I'm going to have less than t here. But I wouldn't mark it wrong if you had in this middle one, t is less than or equal to 30 and greater than or equal to 20, and you just kept your equal signs. As long as the value is the same between your pieces, you can put that equal sign in. But if it's different, if I took a hop up to a totally different level, then I couldn't have my equal sign here. And you'll see that in a minute. Okay. So this is a piecewise function because every piece of this is different. The rule is different. The equation is different depending on where you are in time, or we say where you are in your domain. Okay. Is that okay so far? Any questions on how to write the standard form for writing this? Now let me show you the one place students always make a mistake, and I don't know why this happens, but it happens every single semester. When students write a piecewise function, they forget the equal sign. So don't forget your equal sign. Okay, so make yourself a little note. So later on when you're writing your piecewise functions, to help to remember to put your equal sign in there. I don't know what it is. I think when you write this like brace here, somehow it gets squished or something. I don't know. I see it every semester and I don't quite understand it, but it happens. Okay, so here's my cell phone plan, and this is a true story. I'm not making this up. So you want to read this for us, Ricky? You can yawn first if you want. Were you about to yawn?
Over this allowance charge 45 cents. It's a piecewise function to represent costs for myself. See, it's a monthly cost and the number of months.
Okay, so this is true. I actually went on to my Verizon plan to look this up. It is. I know, I am getting ripped off. What do you use? A track phone? Oh. All right, well, I guess I'll have to start reviewing when my 2 years are up. Okay. So that's why, students are alwaase great. They always fill me in on the latest thing happening. So, all right. So why do I need a piecewise function to talk about this? I have a constant idea going on here, and then I have an increasing idea going on here, right? So where's my constant idea? What part of my domain, or what legitimate interval for minutes used or talked would I be charged a constant amount? 0 to 700. So I can start there. I can start there with my graph. I could start there with I can say if m, because that's my independent variable, is less than or equal to 700. So I read that left to right. M is less than or equal to 700. Now I'm going to go to the middle and say if m, and I'm going to read right to left, if m is greater than or equal to 0. So there's my first part of my domain from 0 to 700 minutes. And at 0 to 700 minutes, even if I didn't talk at all that month, I'm still going to be charged $79. And at 700, I'm $79. Okay, so those are solid dots. And then I have a horizontal line that represents the constant.
But wait, so if you get 700 minutes, if you get to 700 minutes, charge the rate?
Nope. I'm allowed to talk 700 minutes for $79. Okay? So I got 3 phones on this. So I'm watching those minutes like almost every 5 days. I check my minutes. Okay, I got 3 phones on this, and we all have to talk less than 700 minutes a month. Okay. Now, what happens after 7? Oh, so what do I put here? What is C of M if M is in this interval? What do I write here? 79, right. That's my cost if I'm in this interval. All right, now the next part's a little tricky to write algebraically, but I know you can write it algebraically if you just do it with a number first. So I want you to figure out what would be the cost for 800 minutes at your seats, and write out everything you're doing in your brain. Write it out, and then we'll translate it into the algebra when we make that just a variable m. Okay, so figure out the 800 minutes, and then we'll actually write the equation. So what did we get for C equals 800? 124. Okay. And now let's replicate the thought process that you went through, and then we'll write the equation. What's the domain? What's the piece of the domain here? How will I describe that piece of the domain? If we're looking at this graph, where will we be going? We went from 0 to 700 for $79. What's going to be the next part of my domain? Well, why are you stopping at 800? I'm trying to write this for anything in general. It would be 800 if we were stopping at 800 minutes. So how would I write this second part of my domain here? M is greater than 700. Okay. So if M is greater than 700, what would be my formula here to figure out my cost? So let's look at what you did to get the cost for 800. So can someone describe their thought process to get the 124? What you did with the arithmetic? Perfect. Okay. So what if I had 900 now? What would happen? What would change in this blue formula right here? This. So this is the number of minutes that's over 700. So now I replace that with my variable m, and there's my formula. So I have my cost, $79 from my previous level, and then I'm going to make some addition to that, and that's going to be 45 cents for each minute that's over 700. And the way that I represent that is by this expression, m take away 700. That's going to tell me how many minutes I am over 700. Once you tell me what m is. Mary? No, I would leave it just like that. That's what I would do, but if you want to simplify it, you could. The reason I'd leave it like that is I get to see with how this 79 comes into play, but you could simplify it. I wouldn't mark it wrong if you simplified it. In other words, if you distributed the 0.45 and then added your like terms, that would be fine. All right. So this is how we write it. So let's figure out C of 535 together. Let's do C of 535. So someone want to lead us to find the cost when we have 535. Oops. So how would I draw the rest of this graph? So the rest of this graph is going to have a positive slope, and it's just going to continue on forever and ever. So it looks just like that. So this piece is defined by the $79, right? 79 equals C of M. And this piece is defined by C of M equals 79 plus 0.45 times M minus 700. Okay, so one is a horizontal line and one is a line with positive slope. Right. So how do we do C of 535? 79 plus right. Do I have to add anything to it? No, because 535 is in the domain from 0 to 700, which is where I don't get any additional charges, right? So that's just 79 bucks. Now, this is the part you need to pay attention to, because between your exam and some of your projects, you're still not getting how to write a sentence to explain what a particular point means. So this is what I would suggest doing. First, find the coordinates for your point. The coordinates for your point is 535 and 79. Then what I would do is right there, I would put on my units like this, 535 minutes, $79. And then I would use that to write my sentence and make sure that my sentence has each of those numbers in it and each of the units. So for example, if I talked for 535 minutes, there's a zillion sentences you could write. My monthly charge would be 79 buckaroos, okay? So do you see both numbers in both units? So what I'd like you to do now is I'd like you to figure out C of 850 and then write an interpretation for that. It is expensive, but I don't go over. Okay, so if I get close, I just turn my phone off. Oh yeah, if it was 45 cents a minute, it'd be, yeah.
Like it's considerable.
Right. Right. Absolutely. So when you're trying to get a cost and you see your input is 850, you got to go up to your piecewise and say, where does that 850 live? It doesn't live in the first piece of the function. 850 is greater than 700, and this tells you which formula you use to calculate it. Okay, so I think everybody successfully got 146.50. Is that correct? Okay, and then it says that if I talk for 850 minutes, then my monthly blah, blah, blah is $146.50. Okay, so let me just say something. If you take shortcuts when you're writing out stuff for your exercises or your homework, if you just don't do it or you just take shortcuts, you're not going to build the habits that you need when I'm asking you this on a quiz or an exam. So please try to take your time and write the sentences that describe what these things mean. Okay. So here's a regular old one, okay, where there's no story attached, but the picture is going to be two different types of graph, okay? And if your domain, if your value of x is less than 1, what type of picture will you be? What type of graph will you look like if you're less than 1? Less than 1 is here. And what defines less than 1? What type of graph? A quadratic. What does x squared look like? Parabola, right? So you're going to be, are you going to be the whole parabola? No, you're only going to be a piece of it, right? Because the whole parabola goes over what domain? Yeah, from negative infinity to positive infinity. It's all real numbers, and we're not looking at the whole number line yet. Now, Lenny, what if I'm greater than or equal to 1? What kind of graph would I have? Lenny? Straight line. Anything else you can tell me about that line? Let's see. What's the negative slope? Because the coefficient in front of x is negative, right? You could write this as negative 1x plus 1 if you wanted, right? So to make this be a little clearer, I'm going to do every 2 lines is going to be my integer value. So this is 1, 2, 3, 4, 5, 6. And negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, 1. No, then for my y scale, every tick will be a 1. Okay, so I start off by saying, okay, I'm just going to draw this parabola as if I was drawing the whole thing. I'm going to not pay attention to the fact that it's just less than 1. So if x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 4. If x is 3, y is 9. 5, 6, 7, 8, 9. And since I know this is even, has even symmetry, I don't even have to bother. I know that there's going to be a corresponding point at exactly the same distance from 0 on the other side of my parabola. So here I go. I draw my parabola. Boom, 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 boom. And I stop at 1. I don't need the rest of my parabola. I'm going to erase it. Okay. Now here's my question. That point right there at 1, the coordinates are 1, 1. Do I put a solid dot in there? Why not, Shane? X has to be less than 1. So I at least draw my parabola up to that point, and then I just put an open circle at 1, 1. Okay? And if I was 0.9, I'm going to be defined. If I'm 0.99, I'm going to be defined. But if I'm 1, I'm not defined, using x squared as my equation. Okay? So for all values less than 1, I look like this. I look like the baby, you know, my regular old parabola, except right at 1, I'm not defined to be 1, 1. Okay. Now, where does my line start? It starts at 1. So if I'm starting at 1, my equation is going to be 1 minus x. So I put 1 into my equation. F of 1 is going to be 1 take away 1. My value is 0. So my point is 1, 0. So at 1, I'm 0. There I am. And now I could either get the rest of my points by just plugging in some values into my equation, or I can just use the slope of my line. The slope of my line is -1. So that tells me I go down 1 and to the right 1. Down 1 and to the right 1. Down 1 and to the right 1. Forever and ever and ever. Okay? So I just draw my line with a slope of -1 from that point out. And there I am. That's what my graph looks like. That's what my piecewise graph looks like. Okay, so if I take all that out, there I am. Okay, so notice we have a jump or a gap at x equals 1. Okay, notice there's a jump here. So that's why I could not have an equals 1 up in this piece and an equals 1 in this piece. It doesn't work like the swimming pool one. Because if I had an equals 1 here, then I'd have that dot filled in, and then it wouldn't be a function anymore because I wouldn't know what my identity was when I was 1. Am I defined to be 1, 1, or am I defined to be 1, 0? Okay, so we had one of these pictures when we first were learning about the vertical line graph, vertical line test. Okay, so you're a parabola up until 1, and then at 1, you're 1, 0, and you're a straight line with a negative slope forever and ever. Any questions on how to draw that piecewise function? Any questions at all? All right, so let's move on. So before we do greatest integer function, what I'd like you to do is I'd like you to try this first.
Sorry, I had a question.
Yeah, okay.
So on the last page,
Last page. Here?
yeah, how did you know that the negative?
Because I looked at the equation for my line, and it's y equals mx plus b. So the coefficient in front of x is -1. Okay. So what I'd like you to do now is start your exploration. I'm going to let you work on this exploration for like 10 minutes or so at your seats, and then we're going to do the greatest integer function. Adam? No, under 12. It doesn't say 12 and under. Okay, under 12 means if you're 12, you're in the next group. Okay.